All right. Welcome, everyone. I am so glad to have you here today for Tea and Tech. Especially happy to have Brendan O'Brien here as our featured guest. Brendan, would you mind telling us a little bit about yourself?
Sure. I'm old. You can see the gray hair, so I've been around a while. um,
You've
I
earned
actually
them.
I earned them, every one of them. Yep. This one here is dealing with SQL problems and transposition and whatever. No, I started I started programming actually in high school in 1986. I was a junior in high school, so there you go. I've told you how old I am. Uh, a guy down the street was a professor at I believe at Wright State, and I was getting into programming in high school, programming basic, and he said, "Well, if you're interested in this, I'll give you a job." And so I was writing software in junior high in 1986 when hardly anybody even had computers, uh, doing controllers for CNC machines. Using compiled basic. So I
Nice.
wrote a lot of the help system. Yeah, you've dealt with some of that. Yeah. So
That is so old school.
oh,
Nice.
very. Yeah. So we'd written a little 2D emulator. So you'd put the codes in that would be sent to the machine, and it would give you basically you'd pick whether you wanted plan or whatever, and it would show you what the part profile would look like. So we actually worked out how to do that on those old machines. It was computationally intensive, shall we say. You'd see it sort of scan in as we calculated each line. It was pretty funny, but um, yeah, that was actually a lot of fun. It really hooked me and got me hooked into computers, and so I ended up going to Ohio State University, where I got a degree in computer science, um, and spent about 10 years in Columbus doing a whole bunch of different things. I worked for consulting firms, and you know how it is. If any of you have done any consulting work, it's your boss comes in and says, "Hey, by the way, you're an expert in fourth dimension," which is an old database tool. If probably nobody knows about it. Um, yeah, and you had 3 hours to learn this thing and then go impress a client with it. So I'm sure you've all been there. But it was good because it really taught me how to learn new tools. And so even to this day, I'm not, I see an awful lot of people who are very single language oriented. Like I'm a this, and I've always been a multi-language person because of things like experiences like that. I use the language that I think is appropriate to the job that I need to get done, and that maps onto that better. So anyway, I spent about 10 years up there, and then ended up moving back to Cincinnati. I was dating a vet who graduated from Ohio State, who came down here, and she moved home, but I didn't. I stayed. Well, I was already moved home because this is where I grew up in Cincinnati, and spent many years working for Quest Diagnostics here locally, and then ultimately shifted over to Kroger Digital when that was the thing. And it was funny because at Quest I was a manager. I was managing, I don't know, 40, 50, 60 people, something like that, on a project, and QA and the whole bit. And then I went to Kroger and I was a developer again, and that was a hell of a transition, I have to tell you. And then after a couple of years, they
So
invited
I
me
have to
to.
ask, Brendan, positive or
Yeah.
negative transition?
Initially, I thought it was the worst mistake I'd ever made in my life. I have to be honest. I was sort of like, what in the world was I thinking? And I took a pay cut too to switch to Kroger, but the environment and the culture at Digital was so amazing compared to what I was experiencing at Quest, that I decided it was worth it, and we were able to support the reduction in pay, and so ultimately it ended up being a fantastic thing, and really great. And I really, in a lot of ways, it rekindled my own passion around technology, because the culture there was so much about, I'm going to learn all the things, and it was just fabulous. So and then after a couple of years of writing, at that time I was writing client code, so I was doing JavaScript in the browser. Um, But I mean, over the years, I've written a lot of C and C++, tons and tons of services, written a lot of RPC, REST. I never got to do SOAP, thank God. And then, yeah, after a couple of years, they asked me if I was willing to become one of the architects here at Kroger. And I thought about it and I decided that I would. And that's what I've been ever since. They've asked me a couple times to maybe consider becoming a manager again, but so far I'm really enjoying being a technologist again. It's an awful lot of fun, and I don't get to code as much as I used to, although I still keep my hand in. You know, we joke, all the architects joke at Kroger that our IDE is PowerPoint. So, yeah.
I thought it was draw.io.
That's fair. I probably do use draw.io a bit more than PowerPoint, if I'm honest. That's probably true, especially because I use a Mac, so I can't use Visio.
I was going to say Visio is typically the go-to, right?
Yeah. But yeah, since I use a Macintosh, I guess that would be the other thing is
start a virtual box, right?
Yeah, I was going to say I have all three kinds of computers in my house. I use Macs, I use Linux, I use Windows. I don't really care. I guess that kind of describes me in a nutshell. Like, as a technologist, I've always been, I want to learn the pros and cons of each of them and then understand how those apply to different kinds of problems. You know, I've taken that same approach, I think, a lot with, anything. If we look at, like, right now, everybody's microservices, but already we're seeing the trend back towards monoliths because, in my view, people keep trying to apply microservices to problems that need monoliths, and they see that and they go, oh, well, I better do monoliths then. And then they do everything as monoliths and realize, well, that sucks because they tried to apply monoliths to something microservices would have been better for. So I try as much as I can to really examine the problem and understand the tools that best apply. Like, you know, it's the old adage about everything looks like a nail when all you have is a hammer. I think software, for some reason, our field more than any other I've seen, really falls victim to that kind of mindset. So anyway, okay, I've droned on long enough. I'm sorry. I am a talker, so you might have to, like, tell me to shut up.
I love it. Good stuff. There's so much history there.
Yeah, I've seen a lot. Oh my God. I tried to calculate how many languages I learned over the years, and I think it's upwards of 50 programming languages that I've used. One where, you too, Mark?
Yeah, and it's like especially when you count DSLs and you count some weird vendor thing that belongs.
Oh yes.
You know, I did one thing. Oh gosh, what is that? Oh gosh, what is that weird language? It's Lua. I did like one thing in Lua because it was the only thing supported on that platform, and yeah, you get up to 50 really fast.
That's why I did PHP. I had a server I had to solve a problem on. The only thing, I had no rights to install anything, and the only language they had on it was PHP.
It was a WordPress plugin. It had to be PHP. Yeah.
Oh, I hated PHP. I can't even lie. Not a fan.
Do you know RPG?
Okay. Yes, but I won't admit it on a resume. The same thing is true for COBOL, by the way.
I love COBOL.
I did COBOL. I will not put that on a resume.
There's some money there right now, from what I hear.
You know what? I don't need it that bad.
This is the third time today I've heard about RPG, like,
seriously?
Not in the game. Yeah, we have these campaigns at work that say things like, the one that came up today was, it says SQL by day, RPG by night, and it shows like a computer, and then it shows like a D20. Yeah. And some people in the comments of this ad were like, did they not realize that RPG is also a programming language? And so our poor marketing girl was like, she's like, well, like, are they mad? And I was like, I think it's kind of a fun little Easter egg for the Uber nerds myself. So,
Absolutely.
Yeah.
What the hell?
Let's be honest. Both meanings of RPG, there's a Venn diagram with a certain amount of overlap there, right?
Oh yeah.
But here's the thing. At least back in the day when RPG was actually in use a lot, and it hasn't gone away completely, but
no,
I think RPG was like exactly 100% incompatible with SQL. Because it was hooked into that whole runtime that had DB2.
Oh yeah, that's true.
Right? Everything was ISAM. Oh yeah, old school stuff was great.
God, ISAM. God,
yes.
I did a lot of stuff on AS400s too for a while, and yeah,
which is a pretty neat environment. But
it was interesting, like where your file system is a database. Isn't that an interesting concept?
Yes,
absolutely fascinating, and you could do some powerful things with it, but ultimately it was so weird.
Okay, everybody else, this is a commercial system that did not have subdirectories. That wasn't a thing.
Nope, not a bit. Yeah,
the file system was flat.
It was a DB2 database, effectively.
It was crazy.
Why?
I never understood why they made that particular design decision. They could have made
IBM DB2, right? I mean, IBM owned DB2, and so that was obviously, if to the extent you were going to use a database, they were obviously going to use their own. There were some advantages to it, though. Here's the thing: any file could be queried.
Yeah, because it was all
like a database. Because it's a database, so it's essentially a table.
There were no text files, basically.
You'd be really good at naming things efficiently, I'd imagine.
You had to definitely pay attention to that sort of thing. You know, and of course it was mostly supported by green screens and stuff, but then we'd connect to it remotely, and it was amazing because we had third-party software running on there, and it stored all of its files in the database. Well, we had access to it because you could use ODBC to connect to it and query all the same files that the commercial software used and pluck out anything you felt like. There's no proprietary. Oh yeah.
You sicko.
I know. Twisted, right? It was fun. Oh, that's not even the worst thing I've ever done. My worst project, I had a crazy project. I had to use a protocol analyzer.
Oh God.
Because I had to interface with a system that they'd lost all the documentation to. And
so you had to like reverse engineer
I had to reverse engineer the entire protocol by putting a protocol analyzer on the network cable. And it's, for those of you who've never used one, it's kind of like Charles, except it's a hardware device with its own screen, and you plug the network cable into it from the computer and into the wall. So everything passes through this thing, and it unwraps all of your packets and shows them to you on this little
it's like orange and black for your network. Yeah.
Yeah. Yep. A little orange and black, old school chrome, monochrome screen. And it had little controls on it to scroll back it up, and had a short buffer on it, and you'd send commands and see what it sent. And oh my God, that was, yeah.
Back in my day.
I know. Back when things were much stupider, let's be honest.
Stupid.
Which we'll all be saying in 10 or 20 years from now.
Absolutely.
JavaScript was stupid.
Yes.
For sure.
Get off my lawn. Yeah.
I mean, we can already start with back when 2020 was stupid.
Right.
True.
Yeah.
True.
Yes.
That pretty much, that went stupid almost immediately.
Almost immediately.
Yeah,
So bad.
that one was good. Anyway, but some of that was really fun too, because the truth is, getting to do stuff like that gives you such a deep understanding of how all these things work and why they work, and like you want to understand. Excuse me. You want to understand the 7 layers in the network stack? Try reading them literally on a screen up to the wire. You see it, it's all there. And the truth is, no matter how far advanced we get, the stuff that I was dealing with back then, that's all still there. Memory management's still there. The heap and the stack running into each other. Those are all real problems that still exist. They're just sort of hidden. I'll give you a great example. This happened a couple of years ago. I was working with somebody, and they'd used a linked list because they thought it was a fancy array. And happened to be this happened to be in Java, but they used a linked list, and they were complaining because their loop was horrible because they were iterating through it. And and they were trying to go to the 5th item and the 6th item, and they were treating it like an array, which meant they were starting over from 0 every time. And they didn't understand why their performance was so bad. And I was like, okay, come here. And when I was in school, I don't know if you guys have to do this still, but when I was in school, I had to write a linked list and a doubly linked list and a B tree, and I had to write those for myself in C. And so I took them to a whiteboard and I said, here's what a linked list is. And they're like, well, no wonder it's slow. And smart person, right? It wasn't that they were brilliant. They just, but didn't know some of those nuances.
You'll actually have to help me. Is a linked list, is that when there's an object that holds another object with a reference to it in a giant chain?
That's exactly right. Yep.
Okay.
And a doubly linked list has a pointer each direction, right?
So you go backwards.
So you can go backwards.
I have to say, I've never run into, at least that I've been aware of, a use case for that in my,
For what, a linked list? Oh, I can tell you.
Yes.
Here's when a linked list is awesome. If I mostly want to read the data in sequence, like a stream, when I use it. In other words, when I use it, I'm going to start at 0 and just walk the whole chain. And I want to be able to quickly insert something in the middle anytime I feel like it. Linked lists are brilliant.
That's a linked list. Yeah.
That's what they're for. Because
again, not a thing you do very much.
It's not a thing you do very much.
A good example, wouldn't that be like your file browser going back and forth, or like a web browser going back and forth between pages, like forward and backwards buttons?
Except no, actually, that's more of a. I would think that's more of a tree. Actually, I think that would be like a. Yeah, I think that would be more like a B tree.
Binary tree with 2 options each. Yeah.
Well, maybe not a B tree. Actually, you're right, because there's more than one option off each page. But yeah, when I actually worked at a company, well, it was MedPlus, which became Quest Diagnostics. They got bought, and a bunch of guys wrote a web browser interface for the thing, and they were modeling state, unfortunately, on the server. Ugh, never do that. And the now that I think about it, Adam, the data model that they had to use to understand where the browser was a forest. So every time you branched off, all the places you could go from a given page were the branches off of that particular tree. And then you'd get a forest because at some point you'd chop off the history because you can't keep it forever. And so when you chop off the oldest rows,
it is.
That leaves you with a forest, right? Because you've lost your root. Does that make sense? And by the way, it never worked right because IE was the browser, and IE does weird random crap.
IE sucks.
I'm shocked.
Yeah,
So
I mean,
bad.
if you're trying to say
So
something
bad.
works and you're using IE, you're automatically just failing.
Yeah. You literally, it would refetch pages and you'd never know why, and we'd be updating state, but the browser didn't have a different opinion of state. And yeah, we had a memory leak because of that. And that they'd also, the people who wrote the server side of it had just read about Lisp. And so they built the whole thing with continuations, but they did continuations in C++, which doesn't natively support continuations. And so they built it themselves, but that meant they had to build their own garbage collector. And the garbage collector was operating at n cubed. And so as the memory leak went up, more and more nodes that it had to try to collect to throw it out. After about 30 minutes of using the application, response times were in minutes.
Yep.
It was astounding. And, and we went into it and I was like, well, the strategy that was hurting them was the one that actually pruned the oldest rows out of the thing. And I pointed out to him, if you just made it a queue with a fixed link, every time you pushed a new one on, the old one would drop off. You don't have to walk that whole thing. So we fixed that. And at least there was still a leak, but at least the time growth was linear then and pretty flat.
So Brendan, you mentioned something, and I just want to, we tend to have a lot of newer developers in here, and I just want to be sensitive to that.
I apologize.
And no, you're all good. I think you brought up a really important concept, talking about Big O notation. I assume there may be some people in the audience who are not super familiar with Big O. But maybe that's an incorrect
people in the
assumption.
audience who learned about Big O and then forgot everything they knew about Big O.
Gotcha.
Stella.
Oh, they do talk about Big O at Tech Elevator. That's good.
That is good. I mean, it's a useful tool and it's worth spending a little bit of time on because it can really help you in
It's
terms
not
of
obsolete.
No, I don't think it's obsolete at all.
That's actually one of the most important performance things I've learned personally.
And there's more than just Big O. There's Big Omega and Little O and Little Omega, and they all depend on whether you're analyzing best case, worst case, average case, things like that. But the fundamental idea behind Big O notation, I assume you were asking me to give a sort of
if you could, I think that would be excellent.
brief explanation of what it is. So if I have a loop that iterates over an array, we're just going to start with an array, but it could really be any stream of data. If I iterate over that array one time and spit out an answer. So let's say I'm summing the array. That is order n. So what that means is the processing time, the number of operations that I'm going to execute, is proportional to the number of elements in the array I'm processing. So if
and
my
essentially
array
being the number of elements in the array, right?
n is the number of elements in the array. That's exactly right. Now, if I want to sort using bubble sort, that's order n squared. And the reason is, for every element, I'm going to go through and compare it to every other element. So that's effectively 2 loops, right? I've nested 2 loops together. So the number of operations I'm going to do is n squared, right? Because the inner loop's going to be order n, but I'm running it n times. So that's n squared. If you get clever and you use something like quicksort, you can bring that down, and it is able to not compare every element to every other element. And so that brings it down to order n log n, because it does not have to run the inner loop for every other element. And so it's log n instead of a whole nother n. So our garbage collection thing that I talked about was n cubed. So the growth rate on that thing, you've all seen a cubic, right? You've graphed an x cubed before. That's what it looked like, is our number of elements that we had failed to collect in our history grew. It was a hockey stick. It was terrible.
So every algorithm is fine on a tiny data set. They're all
absolutely
fine.
They all work great.
But if you have 10 times as much data, you make the runtime 10 cubed slower.
1,000 times.
So it's 1,000 times slower. Yeah. That's what the whole n is.
Yep.
So instead of taking 5 milliseconds, it takes 5 seconds.
Exactly.
And the user notices.
Lost me when you got to like the log n. The n squared, n cubed, like I can figure that out.
All right, so let me explain. How much do you want to dig into this?
Like 5%.
Okay, simply, the inner loop only has to go from where you are to the end instead of going the whole way. So the first time you run the inner loop, it's n minus 1, but the second time it's n minus 2, then n minus 3, then n minus 4. If you add all that up, it's log n.
So if I may, just to simplify for those who aren't super familiar with log, because that's a lot of people, I know I tend to lose track of that one.
Oh, sure, yeah.
So log of 10 is 1.
Right.
Log of 100 is 2.
2.
So you can see how that would drastically reduce your complexity.
But let's talk about why that's true. 10 to the power of 1 is 10. 10 to the power of 2 is 100. So the log base 10 of 100 is 2. It's in the same way that multiplication and division are opposites, log and exponentiation are opposites. It's the reverse operation.
Cool.
Mm-hmm. I loved math in college. I did a ton of it. So and that's been incredibly useful throughout my career. Sorry.
I was hoping
you
were.
That. It's just weird.
I was going to ask because I know complexity and the big O notation aren't the same thing, but I was wondering, since you're a math nerd, if they have any overlap in the theory, or if it's just 2 different. Yeah. No,
they do. And like when I took at college, when I learned about big O notation, that was the same course where we talked about NP completeness and NP hard. That was all related because it all has to do with algorithmic efficiency. And in that course, I had to, it was actually a really fun class, hard, but it was fun. And so we demonstrated, he actually taught us how to prove that a problem was NP complete. His rationale being that if a boss ever assigned you a task that you weren't sure could be done, if you could prove it was NP complete, you could go back to your boss and say, sorry, this isn't possible in polynomial time. Hey, I see that book.
Whoa.
Which book was that, Izzy?
It's my class. It's my textbook for my automata class in college where we did like NP complete, NP hard.
Yep.
Yeah.
And this was my favorite textbook.
Yeah.
And I
Did you do
kept it
finite-
for a decade.
Did you do finite automata as well as part of that?
Yeah, deterministic
Isn't that
finite
fun?
automata, non-deterministic
That's
finite
fun.
automata.
Yeah.
Our professor taught us about non-determinism in terms of Harry Potter. So like he
My
had
class
So
didn't.
for you.
yeah, it's so perfect. Like I had this lecture memorized at one point, but it was like non-determinism is like tapping, because you have like multiple paths to go down, right? And non-determinism is like tapping each of those like paths or boxes or whatever, and like saying a magic spell and just like randomly picking one and seeing if it was right.
Yeah.
And so that's how I learned about non-determinism.
Oh my gosh, there's a whole bunch of, I just noticed there's a bunch of stuff in chat. I'm so sorry, I haven't been looking at that.
Chat's
It's
just
good
the
to-
peanut gallery. You can ignore it.
Okay.
It's all good. Yeah. So
I-
I dropped in
In
a
truth,
link
I probably
that's-
can't read it and chat with you guys at the same time, so maybe I won't try.
So if this stuff interests you,
If it's
and
too
you
deep,
don't,
we could bring it up. I
think we could do to bring it up just a little bit. But I do want to say, if this stuff interests you, and you don't have a comp sci background, I do recommend the Imposter's Handbook as an excellent option.
Aha.
Nice, Randy.
Randy has it for us.
Nice. So
That's where I learned all of this.
cool. All right, good.
Yeah. They're
That might have been
useful
my
tools.
recommendation. So hopefully you don't hate me for that one.
Oh, this is great.
Yeah,
I did not know this was a thing. I love it.
Yeah, I
Rob
wasn't
Connor's
aware of that
pretty
book.
cool.
I may have to go.
You can
may have to go
pay
get
for
that.
bullshit. Wow.
I've
I've been doing it for free all this time.
all this time. I know, right?
I dropped non-deterministic in an interview because they wanted to get all of the users to be compared to other users, what they wanted. And it reminded me of, in this book, they say he found out later on that he had a literally unsolvable problem.
Yeah.
And I dropped that knowledge in there. I didn't really understand the concept too well, but I said, I'm going to compare this and see if it's non-deterministic or if it's something that we can do in a reasonable amount of time and
Yeah.
change the algorithm. It worked really well. I got the job.
There
Well
was,
I haven't really used it honestly, but it was cool.
there was
I
a
think
comic,
they're more useful. I'm sorry, as you go.
sorry. There was a comic that my automata professor used to show us, and it was like when we were talking about like non-determinism and like NP complete problems. Like if someone ever asks you to solve it, you just say like, I can't solve it. And here's all of these famous, super smart people like Edgar Dijkstra who can't solve it either.
Exactly. Claude Shannon said, I can't do this. I'm sorry.
I
the
actually
truth-
used that once.
Have you really? Oh, I've never had a problem presented to me yet that I could prove was NP complete.
I couldn't prove it was NP complete, but it was. Am I citing Shannon's law correctly? That it's going to take too long for me to go into the
okay.
background. But basically, somebody gave me a problem that was basically would violate Shannon's law, and I just said, "Yeah, that's
Okay.
actually not going to work. I can tell you
Right.
right now, it's not going to work."
Right. That was what was the most fun about that class, was in order to do it. So there are a set of problems that are identified already as NP complete. The traveling salesman problem, the 4-color map problem, for hopefully people know at least one of those. What was interesting was in the class, what you had to, in order to prove something's NP complete, you have to prove that those are actually the same problem.
Yes.
So it turns out the same algorithm that solves the 4-color map problem also solves the traveling salesman problem. And the way you do it is you have to map the inputs and the outputs onto the other problem space, and then you can just run it as a traveling salesman problem, even though it's a 4-color map problem. It's absolutely fascinating, but they're actually the same. They're literally the same algorithm. It's so cool.
We did a lot of that in my automata class. It was
Yeah.
so like mind-blowing how like
Oh, it
all
was.
of these massively hard problems are the same.
They're the same problem. And when you see how they map onto each other, you're like, I don't know about anybody else, but I felt like I was just like, you were just like, oh my God. It was one of a couple of moments in college where I was bumping up against the limits of human knowledge in a non-trivial way. I mean, like,
there was always one base problem that we brought. It wasn't traveling salesman. I forget what our base problem was, but we always try to get everything back to that.
To map to that one, yeah.
Yeah.
Well, I think we did the same thing, but I think we did use the traveling salesman as our base. Anyway, it was cool stuff, but it's probably excessively nerdy. We could.
You know what I want to talk about?
Nerdy.
Yes.
I want to
Do you
talk
not know your
about. I want
audience?
to talk about some other nerdy stuff. I think.
Bring it.
First of all, I want to make sure that we give people opportunity to ask questions.
Yeah.
They have
Shut up.
questions. But also at some point, I'd love to get to astronomy and mineralogy because I just found out that about you from your
Yeah.
LinkedIn, and now
Yeah.
I'm super interested.
I'm a big science dork, so.
Who has questions?
Yeah. Nobody?
I'll go if no one else
I have
has
a
one.
question.
Go
Yes.
ahead.
Go, Lisa.
If I heard you correctly, you said you went from QA to development, and it was an adjustment, or
No, I went from being a director. So
director of
I was a
QA,
manager.
as a
No,
or just
sorry. I know why you said I was directing a development team, and it was development, BAs, and QA. So I was managing a group of people that did all of it. I spent a lot of years as a process engineer as well. And as part of that, I really spent a lot of time understanding how all the different pieces of the software development lifecycle worked and how they work together. It gave me so much more of an appreciation for why, as a developer, you'll find that I'm a huge fan of QA. QA is my best friends. I know there's a lot of memes about developers hating QA. If you found my bug, my customer didn't find my bug. That's
Right.
awesome. And I'm not arrogant enough to think I didn't write some bugs. So oh my God, thank you for using the software in a way I didn't conceive of. That's brilliant. I love it. So, my QA partners have, throughout my career, absolutely been my favorite people. Anyway, what were you going to ask, Lisa? I'm sorry.
Oh, I was just wondering about that transition, but it sounds like you did more of a management rather than.
I was a developer, and then I went into management, and then back into development.
Gotcha.
I think that. So I want to just riff on a little bit the QA stuff you're talking about, Brendan. I think that's a sign of a quality developer is serious respect for testers
Absolutely.
and QA.
Absolutely.
When I see that where they don't have that respect, it's immediately like a red flag. Like, wow, that's if you're not saying thank you for the bug report, then.
And not just for the bug report. Do you know how much work it is to go through that and figure out reliable steps to repeat the damn thing?
Yes.
That's worth its weight in gold. Oh my God. You mean I can make this happen over and over and over again? I can solve that. The worst case is problems where it's non-deterministic, right, Randy? Like, let's talk about re-entrant code. If I've got an asynchronous code base, like, something in Node or Go, where I'm doing re-entrant code. So whenever I make a call, it hops out of that chain of code and then it comes back later. And I watch people set themselves up with race conditions and all kinds of non-deterministic patterns accidentally. And debugging that stuff is hell because it's so hard to recreate.
Yep.
So I love QA. I think if you're a QA person going into development, one thing that would be really, really helpful is exactly that mindset of what are the conditions that cause this to happen? Because that very act limits the possibilities for the things that you need to explore in order to look for the problem. And that's often a debugging. Like, it's funny when I talk to QA folks, a lot of times what I notice is different because I think they're both engineers, right? QA people are engineers. We need to treat them as engineers. They are engineers. Many of the ones that I've talked to hate the idea of trying to read through the code to find out where the problem is. They love finding the problem and characterizing it. But the thought of actually figuring out why it's happening and fixing it is like, well, God, I don't want anything to do with that. I'm more on the other side where that process of grinding through it and figuring out how to make it happen over and over and over again, that's horrible to me. But digging through the code's fun.
Thank you. I wrote that down because I'm in QA, new QA person. So.
Are you? Thank you. Thank you. Here, your goal every day should make a developer every day go, I never thought of that.
Yep.
That's beautiful. That's beautiful when that happens.
I finally have an SDET, like a QA engineer for the first time in like 3 years. And I want to bake her a cake like every single day.
Yes.
It's like she's coming up with all of these different ways to use this app that I never even thought about, and so finding so many different bugs and, mindsets that I never would have thought, and making my code better.
Yeah. Troy. Troy's not answering me.
He wasn't connected yet, Brendan.
Oh, okay.
He's still connected. Now he is.
Troy.
Hey. Hey.
I haven't seen you in ages, brother.
Sorry to crash the party, but I finished another meeting and I saw your name and I said, man, I've got to at least stop in and say hey to my brother.
Oh, great to see you, man.
Oh, so good to see you. Sorry to, as you were, but man, I had to stop by.
Oh yeah, I'm so glad you did.
Yep. So what are you guys talking about now that I'm here?
QA.
Yeah,
QA?
we were on QA. Before
Cool.
that, we were on NP completeness and big O notation. So we've wandered a bit.
We've covered a bit of ground today, I think we could say, so far.
So you guys got lost in the jungle a little bit. That's okay.
Yeah,
You know me. That's where I live.
Yeah, as long as you come out with some bananas and coconuts and all is well,
Exactly.
right? With your rum.
Absolutely.
There you go.
Oh yeah, especially with the
Very
rum.
cool.
What other questions do people have?
I know
I'll just
Randy had a
natter
question,
away.
it sounds like.
I have a question.
Yes.
Oh, go ahead. Who is that?
This is Suruchi.
Suruchi.
I'm new
Hi.
to this group. Hey,
Welcome, Suruchi.
thank
Me
you so
too.
much thank you, Michael, for adding me in this group.
You're welcome.
I appreciate that. So I just now heard, Brandon, you have experience in multiple roles like QA, developer management. So did you actually manage QA group and developers?
Yes.
And if so, what are the different strategies you have applied? Because
Oh.
I have been in project management role consistently, or Scrum Master role. So it's like there are different techniques that you need to apply in order to overall achieve the goal. So I wanted to know a little bit more and learn a little bit more from your experience.
Aha. Okay, that's a broad question. With developers, so with developers, the key there is that they have to feel like they're part of solving the problem. And actually, ideally, they are part of solving the problem. So it's not even that you're creating the illusion of it. It's I never went into them and said, go do this thing. Why? Because I said so. That doesn't work. I'm ashamed to say I do it with my children, but that's more tiredness than anything else. And usually they challenge me on it, which means I've done my job as a dad pretty well too. But the vast majority of the time, with developers, they want to do a good job as long as they understand what a good job is. And so the challenge part is helping set the parameters around the problem that you're describing, so that when they solve it, they're solving it the right way. So particularly what I mean is there's a trap that engineers can fall into. I know I've been very guilty of this. I talk a lot about, there's the book of stupid programmer tricks, and I have my own chapter in that book. And one of the things that comes up a lot is what I refer to as building a Taj Mahal. But I don't always need a Taj Mahal. Like most of the time, I don't need the Taj Mahal. I don't have to abstract all the things. I'm never going to get any benefit out of doing that. I'm just adding complexity. And so helping engineers steer through that stuff and really challenging them on, do we need that abstraction? Do we need that abstraction? What problem does that abstraction solve? Help me understand the benefit I get for the complexity that I added. That's a lot of what I would do with software engineers. And then also people skills, which honestly, that was a big thing for me to learn. I am a recovering asshole, and one of the best things that ever happened is I had some friends. I realized one day that I'd sit in meetings and I'd say things to people, and I'd say, if we do this, this will happen, and we'd do it anyway. And it dawned on me one day, I'm not very good at convincing people of things. because I keep seeing these things and I keep pointing them out, and then they keep happening even though I said something. And after a few iterations of that, you can't keep blaming everyone else. And so I realized I was the problem. And I gave some really dear friends of mine permission to call me on it. And they did. Bless their hearts. They were good enough friends that we'd be in a meeting and they'd go, Brendan, right there. And what it did is I wasn't even conscious of it most of the time. And by having it called out to me in the moment, I could start becoming mindful. Mindfulness is a big thing for me. Mindfulness is such a valuable skill. And so I learned mindfulness about how I was affecting people around me. And so as I became a manager, I tried to pass that along to other engineers, where I'd see them maybe treating somebody in a way that, again, I don't think they intended it per se. It's often more that we're so busy focused on the problem, we're not thinking about the people anymore. And you say something offhand and you don't realize that you've just crushed somebody's spirit a little bit. And so making sure that I took the time to work with those engineers and in a safe way, right? Not in front of everybody. I did it in front of everybody. That might not have been the best choice, but it was a little bit painful. But that was huge. With QA folks, I find QA folks often have better soft skills. Not always. And so I'd sometimes apply that there, but a lot of times QA folks do have somewhat better soft skills. With them, it was actually about getting them to break out. So often I find with a lot of QA people, they get very rigid and rote in what they do, and they want to do the same thing over and over and over again and not break out of that. And if there's one thing I would do with my QA folks, it was challenging them. I want you to come up with 3 use cases that blow the engineers' minds that you came up with that. And I would use an example. So my last name has an apostrophe in it. And now, so my software always handles it. My software always handles it. But so many people, they don't want to deal with it. And so they just make it, they say, well, don't put, I'll validate that out of a problem. But the example I would tell is, hey, QA person, I want you to find out what happens if you put 153 single quotes into that field and hit submit.
Yep.
Just to break them out of it and say, try crazy things. Explore the edges. Don't just run the same test. In fact, I'll be honest with you, if I have my way, you should run a test once or twice and then we automate it. I don't want humans doing stuff that a computer can do. And so that's the other things I encourage the engineering side of QA and get them thinking about how do I automate this so I don't have to run this test ever again. And then I can use my creativity to come up with 10 more ways to torture the code.
And a thing about those weird QA edgy scenarios, you go, oh, nobody's really going to enter 153 single quotes, and nobody's going to do that in a productive way.
Mm-hmm.
But somebody's trying to hack in will.
Absolutely.
Because buffer overflows and stuff like that, they're not going to do exactly 153 apostrophes, but they're going to do something with injected code. So
Absolutely.
that's so
little Bobby tables.
You're not just testing, right? You're not just testing weird edge cases that'll never happen. You're also testing hacks.
You absolutely are.
Yeah.
So that was what I spent a lot of time with my QA folks on it. And then the other thing was, when you're going to bring it to the engineers, make sure you can reliably recreate that defect. So make sure you've got the steps so that developer can then go in and recreate that problem over and over and over again while they look at different aspects of the code until they can figure out what actually is going awry. And then also recognizing when this may be non-deterministic and I can't. And so really helping QA folks understand non-determinism and understanding how to recognize when that's occurred. Because otherwise you're chasing your tail if you keep trying to come up with the steps and the steps keep morphing on you. Then you have to understand when you're past the threshold where you're like, I need some help with this one. This may be a different kind of problem. Randy, I saw you smile. Was that at me or something else?
Michael just put an XKCD comic and it just about killed me. It's really funny.
I used to. Back in the day, I used to read those reliably.
I got pretty good takeaways from your answer. I got the notes also. So basically, what I'm looking at it at high level as a PM, I really need to be knowing what is exactly happening technically to test case level and how they are finding the defects and how they are resolving it. So actually digging deep into that, going to the root, helping them, making sure you should have a good people skills in order to get connected more, so that you can ask for help from them and allow them to correct you at any moment. That will grow you. That is the best takeaway I got. Yeah.
Oh, another thing I used to tell developers, if you want to know how your system works, you are not the one who knows how your system works. QA knows how your system works. The other group that I'd send them to, so if they wanted to understand, boy, I don't know what happens in production, because you're looking at the code and the developers are all swaggering around going, I know how this system works. No, you don't. Trainers in QA, they know how your system works. They know it better than anybody else you will talk to. So when the developers were having a debate over how something ought to work, I'd always send them over to QA.
Okay.
What else?
I've got just a beginner's perspective question. Just when as a noob, I see the word architect thrown around, and to be honest with you, I'm not really sure what that means. I feel like it might be a little bit of an interpreted title, but would you mind shedding a little light on what that might mean from at least a business standpoint?
Not at all. In a lot of ways, I would say that architecture belongs to the branch of software development known as design. And the difference is primarily one of scale. So an architect is looking at broad patterns across a big swath of things. So like even today, I'm working on the LAF project that Michael cited in my little bio, location assortment and fulfillment. So in a system, ALF, I know, I always wished it had been called ALF instead of LAF. I campaigned hard for ALF and I was overruled by a VP somewhere.
Damn it. It would need to consume a cat object as well.
Absolutely. But
sorry, that's a joke from like way back.
That's an old joke. Yeah, that's an old man joke. Yeah. So because we're changing the way we think about location at Kroger right now, because of all the things we're unlocking with e-commerce, and as you can imagine, we're a brick and mortar store for 130, 40 years. And that's endemic to the way people think at Kroger, because, I mean, over a tail that long, how could it not be? But as we're doing e-com, now all of a sudden we're having to think about things in very different ways. And the place where the customer picks up the goods is no longer necessarily the place where those goods are sitting while we're waiting to sell them. That for 140 years, that was always true. Now it isn't. And so one of my jobs is to look across all of the different parts of the e-com solution. So I'm looking at a domain around locations, and there's a domain for items, and there's a domain that handles search. There's a domain that handles coupons. There's a domain that handles other kinds of offers, checkout, payments, modifying orders, right? Those are all parts of our big system. And every one of those parts has teams with 10 to 30 people on them. And there's people in those spaces who are designing those parts. But there's got to be someone who says, well, if we want to change the way we think about location, what does that mean over the whole thing? That's what I do. I help look at and say, oh, okay, there's an impact here, and you're going to have to consider it that way. A lot of what I do is helping design the interfaces between things. So if you're in the item space and you're responsible for, I know all about the items we sell, you're not necessarily hyper aware of what's going on in checkout. You know some things, but it's not really your job. And so that's where folks like I come in. The other thing that architects do a lot is we spend a lot of time on the non-functional requirements. This is a passion of mine because very few companies do this well. Everybody can document functional requirement. Well, okay, not everybody, but most companies do fairly well with functional requirements. I have run into very few companies over my career that have done a good job with non-functional requirements. And here's for those who don't know the difference, I want to explain. So a functional requirement is, I want to be able to submit a cart and give you my payment and then have that order fulfilled, be notified when it's ready, and then go pick it up. Those are functional requirements. It's a function I'm going to do. Non-functional requirements are, I want to be notified within 10 minutes of the order being ready. So that 10 minutes, that's a non-functional requirement. So non-functional requirements are things like scale. They're referred to sometimes as the ilities: scalability, maintainability, performance, security. For some reason, my mind's drawing a blank on all the ilities. There's a ton of them, and I'm suddenly, availability, reliability, resiliency. These are all non-functional requirements. And so we're going to say, okay, this system needs to be up 98% of the time. That's a non-functional requirement. And it's fun. Part of the reason this is passionate to me, you go to the business and you'll say, okay, how much downtime is okay for this system? And what will they tell you?
None.
Anybody? None.
0.
Here's the thing. 0 costs infinity dollars.
Yes.
If you happen to have that in your budget, I'll give you 0 downtime.
Yep.
So now you have to start talking to them in terms of, and this is a key, and this is something I'm going to, all of you, learn how to talk in terms of dollars. Your business partners do not understand code. Don't ask them to understand code. They don't care about it. I mean, maybe some of them do, but mostly they don't. The common language we can all use with one another is dollars. They get it and we get it. So now I can ask this question. Well, how much would it cost us if we were down 1 minute every month?
Right.
And then I can say, here's what it'll cost us not to be down 1 minute every month, to bring it down to 30 seconds every month. That gives you 2 curves. Where they cross, that's your non-functional requirement. That's what I'm willing to spend to achieve this outcome on the other side.
Okay, here can I add to that though?
Yeah.
They understand money.
Yes.
But depending on what level you're talking to, and a lot of time you're talking, it's a big corporation and you're talking to somebody 4 layers below the CEO.
Yeah.
They don't have bottom line P&L responsibility.
Yeah.
And they are not the ones whose budgets are slammed with that 1 minute of downtime.
Right.
So sometimes the unit of measure is not dollars. The unit of measure is looking stupid in front of their boss.
Yes, you can play it that way, but even then,
it really is.
There's a dollar amount that you could probably associate with that. But yeah, that's fair. Yeah, but it just gives you a framework. So obviously it's not the answer every time, but it gives you a framework to understand. You can't come at them with engineering ease.
Oh no,
it doesn't do you any good. And they're going to initially give you answers that are ridiculous, unachievable. Oh, well, the latency can't be more than 3 microseconds. Okay, I can't give you 3 microseconds. That's never going to happen. I could give you 50 microseconds, and here's how much it'll cost you. Are you willing to spend that much money? Okay, did that answer your question?
Oh yeah, you're hitting home on a lot of stuff right now, so thank you very much.
Great.
Can I ask a little follow-up question? Is that okay with everyone? I don't want to hog all the questions here.
Fine with me.
This seems to make sense why data structures models would be especially important to you, or that might be a way that you think. Looking at the bigger picture, sounds to me like you would want to have a visualization of how a lot of things work, And I was wondering
Yes.
if there are higher level, more advanced tools that you use, or just mechanisms like drawing pictures or things of that nature that help you see things from a different perspective.
Drawing pictures is huge. I've done them all. UML, ER diagrams, Jackson diagrams. Oh my God, I've done them all. Do you know what I come back to over and over and over again? Boxes and arrows. I just do boxes and arrows. It just works. I just don't like UML. Half of them, I swear the arrow's on the wrong end of the damn line. And I can't be bothered to figure it out. It pisses me off. Actually, I take that back. I use sequence diagrams. I love those things. I do use sequence diagrams a lot. But it's amazing how far you can get with a box and a label on it and an arrow. That's it. That's all I need. So, that's why I say PowerPoint's my IDE. I can basically do my diagramming in PowerPoint. I do use Draw.io, as he's right. But, and yeah, so that visualization is really important. There was something else you said that I was triggering off of that I went, oh, data modeling. I have seen more systems fail due to a poor data model than any other single problem. If you get your data model right, everything else is easier. I'm not saying easy, but easier. If you get your data model wrong, you will be fighting that battle for the rest of the life of that piece of software. And I'll tell you this, you will get your data model wrong. This is a little bit like the 3 rules of entropy, if anybody knows about these from college, when you did the entropy course. And the first one is you can never win. You can, Danielle, oh my God. Hi. You can only lose or break even. And the second rule says you can only break even at absolute 0. And the third law, this is all the laws of thermodynamics. The third law of thermodynamics is you can never reach absolute 0. So that my physics professor taught me that. No, I'm sorry, my chemistry professor did that. Anyway, this is a little bit like that. You will not get your data model right. So what you want to do instead is design your system so you aren't afraid to change it when you realize you got it wrong. And you might not even get it wrong. It may be you got it perfectly right. Only 2 months later, what you needed changed.
Yep.
So it's not that it was wrong at the time, just the world moved on. And what you need is now different. So you want to build your systems in a way so you have abstractions in the right places, so that when you have to make a change, you're not afraid of it. And another thing that kind of plays into this space, there's an old saying about you're building cattle, not pets. Don't be afraid to just throw it the hell out. Great. If you only used it for 2 months, that's an awesome piece of software that did its job for 2 whole months. That's brilliant. Throw the thing out now. It's not useful anymore. Get rid of it. It's okay. Now you get to write a new thing.
My creative writing teacher in high school had a saying, nothing is ever complete, it's just abandoned. And I think that
That's
really applies to computer science.
That is awesome.
Also, deleting old code is absolutely my favorite thing to do.
Oh my God. Every time I delete code, I'm just like, oh.
I feel so happy every single time.
Yeah, the sky opened up.
Do you know how many bugs I just got rid of? I don't either, but it was a lot.
I have a lot of coworkers who panic when you delete code, but when you delete code, remember you have source control. So
can I tell you sorry.
Yeah.
And if you don't have source control, we need to talk.
Yeah, if you don't have source control, you need to talk.
Oh my God, yeah. Go get source control. Oh my God.
But if you're deleting code, you have source control, so you can always go back to the point where everything was before.
It's okay.
It's fine.
It's like your mom and dad. It's got your back. You're fine.
Set a tag if you want, but yeah.
Yeah, exactly. My favorite story of this, there's a guy named Ron Ross who used to work at Kroger. And he was working on this insanely complex CSS file with we used to do pairing back then. And this thing was 1,000 lines or something, 2,000, I don't know, it was huge, it was stupid. And they were looking at it, and the person was like, I bet we could do something simpler. Can we refactor this? And they started trying to work on it. And Ron said, I love Ron. Ron said, let me show you an old refactoring trick that I learned. Command A, delete. And they started over. And honestly, it was brilliant because trying to weed through that whole thing and structure it better, what a waste of time. It would have killed them. They were better off they knew what behaviors they needed. They had tests to confirm, test for them. So as long as they met them, they did it. Oh my God, it was so funny. But the person, their partner was just like, terrified him. But yeah, Ron was awesome.
It's what Git does, man. It's good. Yeah, and version control does version control, but it also means you can change anything. That's what it really gives you.
That and the tests, right? If you're writing tests, automated tests, well, I know my contract is still met.
Right. It doesn't just test your code. It also lets you change things.
Well, exactly. It lets you change things. And that's the other thing is it's not really testing your code. It's testing your contract.
Yes.
You're not testing your code. You're testing your contract. All I care about the code is if it meets the contract. If it meets the contract, the people calling me can do their job.
Yep.
Because that's another thing people get all hung up on is they start trying to test private members of classes and stuff like that. Don't do that. Don't do that. I don't care about it. It's not part of your interface. If you get rid of it tomorrow, but as long as the public interface in your class still does what it's meant to do, who cares? If you do feel like you need to test it, I will give you a tip. What I've done in that case where it was something very complex and I wanted to test it, use composition. Instead of making it a private member, I made it its own class with its own public interface, tested the bejesus out of it, and then I composed it into my main class.
Yes.
Does that make sense to everybody what I mean by composing it in? Okay. My class pulled that other class in and used it as an internal dependency. Better?
So there's a classic, it's composition versus, what's the other option?
Inheritance.
That's it, yes. And I think a lot of people will say the composition wins. But
in general, there are places where inheritance is brilliant.
Totally.
But I know when I first learned how to do object-oriented programming, I fell into a deadly trap that almost everybody does. I saw objects everywhere. Everywhere. They're not, the inheritance is not as useful as you would think. Polymorphism isn't really as useful as you would think. There are places where polymorphism is brilliant and fantastic, but it's like a lot of the things we're talking, like I said at the very beginning of this, there's so many times when I don't want to apply the wrong tool to the wrong job. People see polymorphism and they start thinking everything has to be polymorphic. No, only things that are actually polymorphic should be polymorphic. It's a tool for a job. Don't use it in a place where it's not the right tool. And never use it in APIs. I hate polymorphism in APIs.
I always get confused about the definition of polymorphism. So Brandon, can you give like high level?
Yeah. Polymorphism is, I want to do a thing, but I have different cases where that thing might apply. So the traditional thing is like in C++, when you're doing it there, you can have several different functions that do a thing that all take different parameters, and you just call it, and whatever you pass to it, the system will figure out which one of those you meant by interrogating the type of the objects that are passed into it. And don't confuse this with pattern matching. Pattern matching is a different abstraction that's used in languages like Scala and stuff. It's really powerful. It's a lovely tool. Polymorphism is not the same as pattern matching. So they sound kind of similar, but they're actually very different. Did that help? Another type of polymorphism is if I have two objects that are, well, here, I'll give you an example. The classic example for object-oriented. I have a base class of animal, and then I subclass dog and cat off of that. Well, that's polymorphic. They're both animals. And if I've got a variable of type animal, I can pass a dog or a cat to it. that's polymorphism. They're different shapes, but I can sort of treat them as the same shape. The downside of that is anything you, all right, how far down to this rabbit hole do we go?
I mean, it's you and me, so we always go down the rabbit hole. So
it is a problem with us. I have to agree.
It is. Also,
so if you think about it, the surface of animal is safely callable from both of those, right? So if dog has a capability that animal doesn't have, I can't call it from an instance of dog that I've stored as an animal. Does everybody understand why that's true? Because it doesn't know it's a dog, so it doesn't know there's an implementation for it.
You can't have a bark method, but you can have a run method or a poop method.
Or a poop method, exactly.
Yeah.
But there's other problems with it. So that when I call the poop method, because that just makes me laugh. And yes, I'm 51 years old, but my inner 7-year-old is still very, very healthy.
Oh yeah.
You know, the cat one and the dog one have different implementations because, you know, it looks through the V table and it calls the one that, you know, so, and of course it can, you know, that one can call the root one, but you can override it. It turns out in practice, it's not useful as often as people think. You know, again, there are aspect-oriented programming is the same way. There are certain problems that aspect-oriented programming is a beautiful solution for, like logging or authorization. But then people want to use it for database access. You're like, what are you doing? That doesn't fit. You actually want a different pattern here. Sorry.
In my professional career, I ran into like one instance where polymorphism like might have actually helped.
Yeah.
But like we were using, thank God, we were using Kotlin at the time, and Kotlin didn't really have like good polymorphism.
Yeah.
And so we weren't able to choose it, which honestly made our code a lot easier to read.
Java really in general.
We had apprentices on our team, and
yeah, the polymorphism in Java in general, and Kotlin running on essentially being a kind of a syntactic sugar on top of Java, because they throw out the type data. It limits some of what you can do in languages that have a little bit richer object system. So like C++, you have the ability to do reflection on objects is significantly more robust, and it'll let you do things that are, well, I'll be honest, stupid. You shouldn't do them, but you can. In fact, the templating language in C++ I learned one day is itself Turing complete.
Nice.
Yeah, I know, right?
I remember hearing about this. Yes.
That's an indication you may have carried it too far, by the way.
Yeah. So I am happy to continue this for a while longer, but it is 5:15, so I know some people may be dropping off. This has been fantastic, by the way. I just want to say,
thank you.
I did set up a Slack channel for T and Tech. Somebody asked me about that earlier, about getting into that. So if anybody is interested, and I can drop that link in here.
Yeah, thanks.
I can do that. And so it's kind of quiet right now, but we'll get there, you know. So, and then what else? Yeah, that's pretty much all I have to say. And if you know anyone who wants to join Team Tech, just have them send me their email or something like that. So, yeah.
You did just create a small world moment. Danielle and I were in Girl Develop It class together years and years ago.
Oh,
and I was like, oh my God, yeah. So, yep.
Danielle helped us get our usage metrics sorted out properly.
I had no idea that y'all work together. It's just a small freaking world.
Yeah. Welcome to Cincinnati's IT community.
I'd just say welcome to the Midwestern IT community. You'd be surprised the connections.
Yeah.
Like, it's wild. Absolutely wild. So I got to drop off though, but we moved our team stand up so I can actually come and join you all a little bit more.
Woot. So. Thank you.
All right.
A pleasure meeting you.
Yep. Have a good evening. See ya.
Take care.
Thanks, everyone. Bye.
So we can keep talking for a little while if you'd like.
Have a little time.
Cool with that.
If somebody has a question.
I have nothing to do until my husband gets home, so.
Yeah, I don't have to do anything until it's time for my wife and I to cook dinner.
I don't have anything to do because really existence is just inherently meaningless. So
A nihilist, wonderful, kindred soul. I may resonate with that statement. I have a sort of a Zen thing where, you know, taking the long view, nothing matters much.
I don't even believe that. It was just fun to say.
You can watch me all struggle to manage 3 dogs by
Three
myself
dogs
who haven't known each other for an entire week.
Oh, good,
Gotcha.
good.
Izzy, you walked away and 2 dogs followed you. And I was like, I thought she said 3. And then a few moments later, a 3rd dog came by. It was so cute.
I'm assuming he was probably the 3rd one because he's the laziest and the oldest.
Gotcha.
Yeah, it was dinner time. So we got our new dog, Thomas the Tank Engine.
Oh,
Saturday.
nice.
That's a good dog name.
Thank you.
It is.
His nickname is Blockhead because he has a really blocky head.
Yep.
And then, like,
How many nicknames does he have yet?
Sorry?
He has several nicknames already, right?
Yeah. So his original his nickname was supposed to be Mr. Mint Hands, but it didn't really work out that well. So we've switched it to Blockhead.
Gotcha.
We call him Thomas, Tommy, or Tom. Thomas for training purposes.
Okay.
All of our dogs have nicknames. So we've got Blockhead, and then we have Squints McGee or Smelly Pants. And then he is Admiral Lazy Bones. He recently got a promotion.
Nice. Working his way up.
Yeah. So it takes a pack of dogs about a month to figure out their pack dynamics. So we get to have fun in the meantime. And Stella keeps trying to start a bark. Like she keeps like thinking she hears a noise and like barks, which is weird because my dogs don't usually bark. And except Thomas is a barker. So she barks, he barks, and then he doesn't make a noise.
Right.
Have legitimately only heard him bark twice in the 6 years that I've known him.
Oh, wow.
Yeah. So.
I use a phrase from Thomas the Tank Engine in my almost daily life. I refer to people as by the thing that the conductor always used to say to Thomas when he messed things up: confusion and delay. I run into so many people who seem that the primary thing they seem to deliver in any organization is confusion and delay.
You're welcome.
Thank you. I'm sure that's nobody here.
Yeah. I just like the fact that in the show on PBS, like Ringo Starr was the conductor for a while.
Oh yes.
Like,
Shining Time Station.
Shining Time Station was the best.
And also George Carlin.
George Carlin. I remember that.
George Carlin doing a kid's show.
Was on Shining Time Station.
He was the conductor.
Where dreams can come true.
Oh my.
He was awesome.
But yes, Ringo Starr doing a kid's show. That's great.
I know. Trying to figure out if that was like a community service sentence or what.
Or maybe Ringo Starr is just awesome and wants to be the conductor of Shining Time Station.
He could be. I actually don't know much about him.
All I know is right now I get to ignore all of my dogs.
Oh, yeah. I know Paul McCartney said the reason they had him in the band was because he could hit the drum skins harder than anybody they'd ever met.
Oh, yeah.
You know, I'm a font of useless information like that.
You're a font of amazing information like that.
Oh, well, thank you. I don't know. Lots of useless stuff.
Trying to start a bark.
So speaking of useless information, my daughter apparently at one point started a Discord channel with her friends about the random bits of facts that I'll tell her throughout the day.
That's brilliant.
But I was moderately famous for such.
Excellent. That must be why we get along so well. I love stuff like that. I really do. And the funny thing is, I don't know enough of it to be useful like in a trivia quiz.
I'm mostly impressed that Reagan started a Discord channel for this because that just seems like it takes a lot of effort.
Yeah. Precocious, I would say.
Yeah. And I do have to admit that over the weekend I was part of a Harry Potter trivia and I wasn't even in the top 5. I know.
That's okay.
No, it's not. My team just wasn't there for me. They didn't really care about having the right answers. They just wanted to hang out with each other. So it was like all in my wasn't cool. I didn't even know until the trivia started if it was going to be book or movie trivia, so I couldn't study. It was rough, guys.
They lacked commitment.
Yeah.
That's hard because when you want to participate so much more aggressively and they don't, you can't quite be the jerk that wants to ruin their fun. I guess you can, but it doesn't end well.
But it doesn't, it never works out.
That.
Yeah.
I do that, but I don't have any friends now, so yeah.
Well, there you go.
Yeah.
Izzy, can you give us a good Harry Potter trivia question that was asked maybe?
So like the ones that are always asked are how many galleons to sickles and how many sickles to a galleon, how many nuts to a sickle. And then the names of the three brothers from the Tale of the Three Brothers.
Gosh, no way.
I need to read these again.
Yeah.
I love those books and can't answer any of these.
So it's
kids might be
17
able to.
sickles to a galleon and 29 nuts to a sickle.
Okay.
I know this because in college, my algorithms professor, who's also my automata professor, gave us some homework problem that had to do with like currency exchanging, and like when a currency exchange like doesn't like match up, so sometimes it's yeah,
that's a great.
And he used galleons and sickles and nuts, and he didn't use the proper conversions, so I immediately his email with like the homework problem. And you're like, no, it's this. And Hager and like I looked up like the page of the book and everything, and he was just like, how did you know that? I was just like, it was off the top of, like, how did you not know that? Common knowledge.
Yes. The reason they do that is so you can't use
because I'm a Harry Potter
answers.
super fan. Sorry, what was that, Brendan?
The reason they do that is so you can't use last year's answers.
Maybe so.
Yeah, I don't know.
I can only imagine they said, your answer is wrong. Like, no, your question is wrong.
Your question is wrong. That sounds like what Sheldon would say.
Yeah, he was my favorite professor in college. He works at Google now doing stuff. I don't really know what, but I did send him a message talking earlier about our conversation about non-determinism and P equals NP and.
Oh yeah.
Yeah.
I love that. I really enjoyed all that stuff in college. It was pretty fun. Discrete mathematics, that was another one I really enjoyed.
Discrete is fun.
Yeah, I really enjoyed that. That one was interesting too because they, at the very beginning of the class, we had this professor, and the first thing he did was ask how many math students were in the class, and there weren't any. This is from the math department. He's like, "You're all computer science, right?" "Yeah, we're all computer science." "Awesome. I'm not going to bother with proofs." So that was the class where they taught deductive and inductive and deductive proofs to the math students. Since there weren't any math students, he's like, "You guys have done this so many times. I'm not doing it again." So we got to spend more time on, combinatorics and pigeonhole theory and graph theory. God, graph theory is so useful.
Is graph theory a part of discrete mathematics? Because I'm looking this up and it looks like I'm seeing nodes here.
At least in our course, graph theory was part of discrete mathematics. Yeah.
That's cool.
And it's amazingly useful. You'd be surprised. Well, think about it. If we talked about how all those NP complete problems all map onto the traveling salesman problem. Well, the traveling salesman problem is a graph problem.
Yeah.
So a lot of problems are actually graph problems.
I was watching a thing where there's 4 nodes connected to each other. Is that called like a community or something of that nature? Does that ring a bell by any chance?
Nah, it's a cycle.
Maybe a cycle is okay, gotcha.
Well,
I'm out of my league here, and I think I need to go research this more.
And let's be clear. My degree was a long time ago, so I could well be, forgetting something. So I don't claim to remember all of it, but like just the thought process for how you approach graphs is something I have used more than once in my career to try and, to help me understand how to solve a problem. Mazes are graphs.
Yes.
Yeah. It seems like, could you argue that so much of just branch logic all breaks down to a graph essentially?
Absolutely.
Cool.
Yeah, if you think about it, all a graph does is describe a relationship between two entities, 2 nodes. That's all it is. Now, obviously here, we're not talking graphs in the sense of a coordinate system with a line plotted on it. We're talking, we're talking, Hamilton and Euler were two of the key guys who did a lot of the math on this stuff. And it's just about nodes connected with edges.
I love it.
Go ahead. I use Dijkstra's algorithm in my everyday life to figure out the most efficient path to get from point A to point B.
Awesome.
I was about to ask if someone could give me a starting point for something to research. Would you mind putting a link to that so I could maybe read up on it a little?
I don't have a link off the top of my head, but I can give you I'll go find a Wikipedia link. So Dijkstra's algorithm is one of the most famous, shortest path algorithms that you can use.
Okay.
Or, if you have a graph of nodes. Probably a lot of mapping software uses Dijkstra's algorithm. I used to think of walking paths getting from my buildings in college as Dijkstra paths. So each intersection or sidewalk would be a node. Yeah. And I would kind of map out what would be the most efficient way to get there.
Yeah.
I'm, that kind of nerd.
Okay, I mean, I just heard that's the coolest thing I've heard in all of 2020 and 2021.
Some random thing I used to do in college in my head.
Yeah. In that way, yes. That's pretty accurate.
Oh, there it is.
If you know graph theory too, those puzzles where you have to trace a shape and you're not allowed to revisit.
Yep.
You can't cross a line more than once. That's all graph theory. And there's a simple formula.
I love that.
There's a simple formula. You can glance at it and determine immediately if there's an answer or not. Just by glancing at it.
Oh, you have piqued my interest here.
Yeah. And in college, my professor that I keep talking about used to say, if there ever was a unit of measure for arrogance, it would be the Dijkstra. And Edgar Dijkstra would be a million Dijkstras, and everyone else would be pico Dijkstras. Because he was super, super arrogant. There was a couple, I don't remember the exact theorems that they were, but there was definitely a couple of theorems that we learned about that someone else discovered, but then Edgar Dijkstra rediscovered it, he could take the credit.
Fermat's pretty arrogant. That guy was.
Well, maybe he's not a pico Dijkstra, but most normal people are pico Dijkstras, and there's Edgar Dijkstra.
I love that unit of measure. I'm totally stealing that. It was so good. Oh my god. And then there's guys who had every right to be arrogant, like Euler, or Gauss, just ridiculously smart people, and they seemingally weren't that bad.
Yes, the Erdős number, yes.
Erdős, yes, the Erdős number.
Yes,
that's just unit of measure. It just reminded me of that because my math teachers love talking about this.
Yeah,
and so it's interesting if you read the article, but basically it's how close are you to someone who has published a paper with this guy?
Yep.
Apparently his name is Erdős. And
he's Hungarian.
Right. And go ahead.
Yeah, he's a Hungarian mathematician. It's similar
very
to
much like
number.
a Kevin Bacon thing.
And there are a few people who have both an Erdős number and a Bacon number.
Yeah, my Erdős number is 3.
Is it really?
Because I know a guy who collaborated with somebody who collaborated with Erdős.
Yeah.
And in undergrad, he helped me with my homework once.
Nice. We'll count that.
So that's a 3.
That totally counts.
I'm taking that.
Okay.
I think Tim might be home or about to be home. I'm hearing a lot more barks. So I'm going to sign off.
Bye, Izzy. Thank you for joining.
It's good to see you.
Yeah, it was lovely talking to you all today.
Thank you, Izzy.
Bye.
Bye.
I'm going to get off too. I'm putting off work. Thank you so much, Brendan. It's great to see everyone.
My pleasure. It's great meeting you all. Take care.
Bye.
Thank you, Brendan. Yes.
My pleasure.
See, Izzy leaves and everybody just says, to heck with it.
Well, it's getting close to dinner time for me. So
it sure is.
I should check in with the family and see what we're doing. So it was great.
Thank you, everyone.
Danielle, so awesome to see you again. I'm really glad you stopped in, even though you didn't say much.
No, I just wanted to say hey and
hi.
See how things are going. So
we're going pretty good.
It's a pleasure to meet you on video. I'm gonna actually go ahead and stop recording.
Yeah.
Now.